Okay, I believe I set that up right. So, well, thank you guys so much for coming today. I really do appreciate it. I know what's going on in the classrooms and things right now is exhausting. So I do appreciate that you guys are giving an hour up of your time in the evening so that we can talk about the Oklahoma Academic Standards for Science. This is going to be an introduction to the 3 dimensions of the standards. So it could be brand new for you. It could be just a review. It's really open to everybody. So I do appreciate you coming. I do want to introduce myself. My name is Heather Johnston. I am the Director of Science and Engineering Education at the State Department. This is month number 4, so we have been moving fast, but I am enjoying it. Our science team at the State Department has several individuals that are a part of our team. Susan Ray, who is the Oklahoma Excel Science Specialist, is amazing, and so is Donna Schweitzer, who is one of our instructional specialists as well. And then Samantha Shepard is new to the team this summer, and she is the Science Assessment Specialist. I am going to put in the chat box a link to our slide deck, just in case you do want our emails for later on. And then I will also put this link back in to the chat box throughout, just in case you do need it. Just to go over a few session norms today, I would love to see who is here. So in the chat box, if you could introduce yourself, let us know who you are, where you are teaching, the grade level and subject area. I'd love to kind of see who is here. We do ask that you please stay muted just because of background noise. If you do wish to ask a question, you are welcome to post your questions in the chat, and you are welcome to unmute and ask the question. I think our group today is not super large, so feel free to do that. You can also turn your camera on if you would like, but I know when I'm sharing my screen, we can't see everybody, and that sometimes bandwidth is a little bit of a problem, so do not feel obligated in keeping your camera on. And then just a reminder that your participation is important, so please ask questions. I am here to help you, and so if something is not clear enough, just let me know, and I will try to make sure that I say it in a different way so that it does become clearer. Just in case you don't know where the chat box is located, I have a little screenshot of what your Zoom screen, if you were on a computer, might look like. And you are simply looking for the chat box that is located down at the bottom of your screen. If you were on your phone, there will be 3 little dots that are your More section, and that is where you will then see the words chat. And if you select that, you would be able to find the chat box there. These other 2 sections today, we are not going to use them. We will not be having breakout groups today, since this one is more of an informative webinar versus an interactive one, but the rest of the series of our OKSci Education 101 will have interactive features, and so we will be using those later on this year. A brief overview of our session today. We are going to identify the different components of the Oklahoma Academic Standards for Science. We will be discussing how to integrate those 3 dimensions of our standards into instruction. This will be a brief introduction because our next session will be focused more on phenomena and what that means and how to actually go through that process. But we will be identifying resources today that can help you support you with 3-dimensional science. With just 1 hour, I didn't want to try to cram too much into it, so we're just going to focus on the components first and then build from there. So let's talk about our academic standards for science. I'll post the link to the standards a little bit later, but they are available on the State Department website. You don't really need the link for it today. Anything that we need, I did take a screenshot of it so that you didn't have to like flip back and forth between different screens. So a little bit of a review on where our standards kind of come from. In 2014, our science standards in Oklahoma shifted from more of a content checklist. If you've been teaching since then, you know them as our PASS standards. So we went from that to more of a performance expectations, which detailed what students should be able to do and what they should know. So it was just a little bit different than what we had seen before. But the big shifts were on what kids were doing, what students were doing. So rather than just like checking off our objectives and things, we were looking at these performances. The standards, they do describe specific areas of student learning that are considered to be the most important for proficiency in that particular discipline. So we know that there's a lot in science education, and these did try to stick to some of those bigger ideas, and they are written in such a way that they progress from pre-K through 12th grade. And we're going to be getting into those vertical progressions a little bit later. The shift in moving from checklists to more performance expectations were informed by the research from the book that you see on the screen, A Framework for K-12 Science Education. This was from the National Academies of Science, and they did put together a lot of research from the last 20 plus years. And this really helped guide what the Oklahoma academic standards for science would look like. And this past spring, we did revise the 2014 standards. It was time for science to do that. And what we did was updated the standards to include play-based pre-kindergarten standards. Those are focused more on the science and engineering practices and getting students to explore through play. We increased the clarity for teachers through the clarification statements, and then we did provide stronger connections within and across grade levels at middle school. More details on those can be found in previously recorded webinars and some instructional materials that we do have available. If it's something that you need, just please let me know, and I can get you links to those. So the first thing that I want to address is the standards layout. It is a little different than the 2014 standards. And if this is brand new to you, then this will also help as we break down each of the components that are here. So every single grade is laid out exactly the same. I do have a third grade example that is on the screen. So of course, right at the top, one of the easiest things to identify is the grade or course. You will also find this at the beginning of the code for the performance expectations. So if this is third grade, that's why you see the little number 3 here. And you can see that down here with this performance expectation, the 3 in front of it. The next box that you will find underneath there, this is the disciplinary core idea category. So we're going to talk about disciplinary core ideas a little bit later, but this is the content, one of the domains that we have. And each domain is broken down into idea categories. So for third grade here, we are looking at motion and stability. And then underneath that, you'll find the performance expectation. The performance expectation does have a code here right at the front of it to identify what the grade level is, what the domain area is, and we're going to go into what that is, our disciplinary core ideas. The PS here stands for physical science. And then the 2.1 ties back to this idea category So you see the 2 here, and it's just the first one that happens to be there. Every standard has a code, and once you become a little more familiar with it, it's a lot easier to understand. So don't feel like you have to memorize it, but it's very similar across the board, so you kind of just get comfortable with it. The next section here is our clarification statement and our assessment boundary, and we'll get into those details in just a little bit. And then we have our foundational boxes at the bottom. And so we have science and engineering practices. These are things that students are doing in the classroom. We have our disciplinary core ideas. These are the science content that students are learning. And then we have the cross-cutting concepts. And the cross-cutting concepts are how students are thinking about the core ideas. All 3 of these build up to the performance expectation, and we're going to talk about how the foundational boxes support the standard. So we're going to work our way from the top to the bottom as we discuss each section, and we're first going to start talking about the performance expectations and the clarification statement. So the performance expectation is the standard. So typically when you hear what is our standards, this is what we are referring to. All of our standards are performances. We expect students to be able to do something with the science content that they are learning. We believe that students should be engaged with their learning, and so our standards reflect that idea. Each of the performance expectations include the 3 dimensions of science. So those foundational boxes that were blue, orange, and green. We have science and engineering practices, disciplinary core ideas, and cross-cutting concepts are the 3 dimensions. One of the clarification statements that we have that are on there, they really help provide further explanation or examples to support educators understanding that performance expectation. So when you read it and you're like, what does this even mean? Inside the clarification statement, it should give you more details and guidance as to what is expected of students. The other component that is right at the top of our standards is the assessment boundary. Now, the assessment boundary is meant to support the performance expectation and relate it to the other standards in that learning progression. So in 3rd grade, when they are learning about forces, those particular students are only expected to understand a particular concept about force and motion. And so the assessment boundary really helps put like the end point for 3rd grade on what they should understand. These assessment boundaries can be utilized to develop assessments within the local context, because it kind of helps you like identify whether it should be a qualitative or a quantitative assessment, or even just the content that you should be including. The assessment boundaries in 5th, 8th, and for biology and physical science at the high school, they are used to develop the state tests. So if you're ever wondering, like, how far will the state test my students, the writers of the questions actually have to use the assessment boundary so they stay within our expectations. So if we take a look at the example that I provided a moment ago, you can see here that our performance expectation talks about planning and conducting investigations on the effects of balanced and unbalanced forces. So students are doing something with this content that is being provided. Inside the clarification statement, it provides some examples for this. So if you're looking at an unbalanced force on the side of a ball, what happens to it? And it discusses like it can start moving. The ball would start moving if it's unbalanced. When balanced forces are pushing on an object, the object doesn't move. And so that is what third grade is looking at with this particular standard. And then the assessment boundary here, it identifies that the assessment is limited to just one variable at a time. So you can only alter the number or the size or the direction of the force. You can't be varying multiple variables at third grade. And then it also identifies that it does not include quantitative force sizes, just qualitative. So it's looking at, did you push harder? Did you push softer? And not an actual value on the force here. And these are provided for every single standard. In 2014, some standards were missing these particular things. And so in 2020, we really tried to ensure that we provided these two supports for each of the standards. The next part that we're going to discuss are the 3 dimensions of science. This is where you hear the terms 3-dimensional science, teaching, and learning. And what they are referencing are these 3 foundational boxes. These boxes, when integrated together, get you to that performance expectation. And so these really help break down what it is we want the kids to do to be able to perform that standard. The first one we will discuss are the science and engineering practices. Across the top of the screen, you're going to see them labeled as dimension 1, 2, and 3. That is just simply because it's the order in which they were presented on the standard document. Just know that one is not valued more important than the other. We just happened to number them in this way. There are 8 science and engineering practices in our standards. These practices, you will be able to find them pre-K through 12th grade. They are the same 8 practices. And what we do is we build on the skills as students move through their education. So what students are expected to do with asking questions in kindergarten versus 12th grade, it's the depth of questioning. So the 8 science and engineering practices that we have here are asking questions and defining problems, developing and using models, planning and carrying out investigations, analyzing and interpreting data, using mathematics and computational thinking, constructing explanations and designing solutions, engaging in scientific arguments from evidence, and then obtaining, evaluating, and communicating information. These are always identified inside the standards. If you are wanting more information about each of these particular science and engineering practices, there are a couple places that we can look for more information. Inside the standards document on page 5, there are a lot of introduction explanations for the standards. So if you're looking for general information about each of the practices, you will find that on page 5. And this is just a screenshot of that particular page. As you can see, each practice has a brief summary underneath of what is expected there. The other place that you can look is actually at the standard. And so within 3rd grade, this particular standard is asking students to plan and carry out an investigation. The specific thing that they should be able to do within that practice is then detailed inside that bullet point. And so in 3rd grade for this standard, we hope that students are doing an investigation collaboratively to find data for evidence. So that in this scenario, that would be like pushing on a ball, harder, softer, pushing on other different things. And figuring out some data, so like gathering the information. this is what they would be doing at 3rd grade, and that is detailed inside the standard. We also have vertical learning progressions for each of the dimensions. And what this means is we are looking at what did students learn prior to the grade level that you were teaching, and then kind of what would they learn after, and what would they do when they build on that. Our vertical learning progression documents, I will link in just a moment, but the example I have on screen is asking questions, and you can see that these are grade banded. So we have K through 2, 3 through 5, 6 through 8, and 9 through 12. And you can see as you go across the increasing complexity of what they are doing with asking questions. And we have that for every single practice. Let me pull that up real quick. So the link that I just dropped inside the chat box would take you to the vertical learning progressions document. It is within the science frameworks. You'll have access to the other progression documents as well, and we will be highlighting those in just a moment. The next dimension that we will discuss are the disciplinary core ideas. As you can see within the standard document, there's going to be 2 pieces of the standard that identify the disciplinary core idea. We have the idea category, and then the actual content that they are learning within that particular category. So right now we're looking at physical sciences, specifically motion and stability, and then here are the science ideas that they would be learning about address motion and stability. There are 4 domains of science ideas, and that's how the disciplinary core ideas are broken up. We have the physical sciences, which are indicated with the PS. We have the life sciences, the earth and space sciences, and engineering, technology, and applications of science. The Oklahoma Academic Standards for Science are really only focused on these first 3. So these are specifically called out in each of the grade levels. Oklahoma integrated the engineering, technology, and applications of science standards. So rather than having them as a separate strand, we applied them to standards that made sense. And so if a standard has some engineering concepts, they are marked with an asterisk right at the end of the standard. Each of the disciplinary core ideas do have a brief description in the standards document. If you were just curious as to what physical science actually covered, or what does the life sciences cover, that kind of thing, that is in there, just like it was for the practices. And then you would want to look at your standard to identify grade level appropriate content. And they are always bullet pointed in this middle box, and they are orange. I do want to point out that the colors did change from the 2014 to the 2020 standards. So the disciplinary core ideas used to be green, but they are now orange. And the Crosscutting Concepts color also changed, just as a side note in case you did not see that. We do have vertical learning progression documents for the disciplinary core ideas as well. This is an example of motion and stability. Here, as you can see, this is a screenshot of the old documents. We are currently updating the vertical progressions for the disciplinary core ideas because middle school had a lot of changes in standard placement this year. And so we just have to go in and alter, modify, update kind of thing, where the ideas are addressed in middle school, but that is coming. So just know that if you go and look at the vertical progressions, middle school is just a little bit jumbled right now. But you can still use it and see like, what did students learn about this topic before getting to my class, and then what will they learn after me? And that again gives you an idea of what is expected for your particular grade level or subject area. Obviously, if you're at the high school level, there's not a lot that comes after you. But that's like through the collaboration then within the local universities and kind of getting an idea of what some expectations are after high school. The last dimension that we're going to discuss are the cross-cutting concepts, and these actually happen to be my favorite ones. I really, really like them because it's the how students are thinking about the science. I know a lot of times when I was teaching, students had a difficult time focusing on a particular idea and weren't quite sure what they should be thinking about. And I really felt like the cross-cutting concepts help give them a lens and a focus. There are 7 cross-cutting concepts that are in our standards. These 7 run through pre-K, well, not pre-K, they run through kinder through 12th grade. And again, increasing complexity, just like the practices do. So on the screen, you can see that we have patterns, cause and effect, scale, proportion, and quantity, systems and system models, energy and matter, structure and function, stability, and change. Sometimes these cross-cutting concepts blend in with the disciplinary core ideas, and so can be hard to distinguish between the two, but that is why the foundational boxes within the standard are really helpful to kind of indicate what is expected of the cross-cutting concept and how that supports the disciplinary core idea. The 7 cross-cutting concepts are described within the standards document. So if you were just curious about the general descriptions of each of the concepts, you could find that there. But what is applied to your grade level is found in that standards document. So in this instance for 3rd grade, students, when they are thinking about these balanced and unbalanced forces, the cross-cutting concept here is cause and effect, which is really great. That particular relationship, right? If I push on this ball, what happens? And so you have your cause and effect there. And really getting students to identify that particular relationship for 3rd grade is important, because as they move through 4th and 5th and middle school and onward, what they do with cause and effect does get more complicated versus just identifying when I pushed the ball, it moved kind of thing. We also identify the learning progressions for the cross-cutting concepts in a similar way as the practices. So they are grade banded, K through 2, 3 through 5, 6, 8, and 9 through 12. And then you can see for this particular example, which is patterns, what students are doing with patterns in K through 2 versus what students should be doing with patterns in 9th through 12th. And we do have these set up for all of the cross-cutting concepts. All right, so before I go into three-dimensional science teaching and learning, I know that was a lot of information about what the standards look like. Are there any questions so far? Okay. So then we can move on to the next piece and talk about three-dimensional science learning. So before our new version of standards, we tend to teach the skills independent of the content. So we may have had a lesson or activity where we were specifically teaching students how to do conversions or how to do unit analysis and how to do science separate from when they were actually doing science. And with our new standards, those things really should be done together rather than independently. So we are moving away from let's teach the scientific method as in A goes then to B, which goes to C, and rather think about how is science done. And science is done with integration. Scientists are doing science as they are learning about what they are investigating. And so within our standards, we really want students to be able to experience that same thing. So when we talk about three-dimensional science learning, we want to think about how can these 3 dimensions of our standards build together to reach that performance expectation. And one way that happens is that instruction builds towards it. So we've really got to think about, they can't just start with the performance expectation. What are the structures students need in order to reach that? While each standard does have a science and engineering practice highlighted specifically for that standard, you do not have to do just that one science and engineering practice, because we know that's not reality. Scientists are always asking questions. Scientists are making observations. They're gathering data through those observations. Then they could be doing an investigation, gathered new information, and have other questions. It's an example I had seen was like a ping ball machine. Make sure I said that. Where you could bounce around and doing all of these different practices. So don't feel like you have to be constrained in doing it in a particular order. We just know that at the end of that standard, they should at least be able to do that one that is highlighted. So if kids are doing science, they can discover the science ideas through investigations. Now, I also want to highlight that does not mean that there will be no direct instruction involved. I taught high school chemistry, and my students were not going to just magically discover how dimensional analysis was going to happen. So some direct instruction was needed. However, there are other ideas that do support that kids can discover through an investigation, right? And so it's just really finding that balance of getting kids to do it, bringing in their ideas, building in the discussions, and then supporting them with direct instruction where it's needed. When kids do begin to struggle, you can also use those cross-cutting concepts to really help direct their thinking. If they aren't quite sure what they are supposed to be doing, you can ask them a question. Well, what patterns are you seeing inside the data that you gathered? And then they could start looking for patterns, and you can start providing that support that helps build them towards the performance expectation. Later through this series, these are things that we are going to be focusing on in lesson development, using phenomena, driving questions boards, student discourse. Those are really going to be the topics of our next 3 meetings so that we can spend time delving into how this is done. So when you get started and you're approaching this 3-dimensional science teaching and learning, you've really got to look at your standard and look at what are the expectations of students for that particular standard. And you can see a little chat box here up in the right-hand corner. So I would love to hear some of your thoughts. If you just take a moment and you read this 5th grade standard on physical science, what do you learn about this expectation from the information provided? So what kind of pieces of information can you gather from this standard? You know what, go ahead and type your answers into chat box if you don't mind. Or feel free to unmute if you'd prefer. We're a little quiet today. So we can break this down just in case. I did start highlighting little components at oh, great, thank you. So students will develop models to describe natural phenomena in the area of physical science. Yep. And she pulled that from the science and engineering practices here. Develop a model to describe something. Great. That's something that we can learn from this. Kids need to be able to illustrate that. Anyone else want to share? Okay, that's all right. So I, just in case, because I know sometimes we get shy, I did start highlighting the different boxes that we kind of discussed earlier. So in this first box, if I was examining it, I would know that this is my performance expectation. So by the time I am done teaching a unit for physical science in 5th grade, my student should be able to develop a model that describes that matter is made of particles too small to be seen. So they should be able to draw a picture and show me that. And so I know that at the end of the unit, that is what they should be able to do. The next section can give me some examples on what that even means, because maybe I'm like, how can they draw a picture of particles that they can't see, right? They just draw a circle and leave it empty. What does this look like? So inside the clarification statement, there are some examples here about building models about air, right? So inside a basketball or a balloon, when we blow up a balloon, right, there's just a bunch of air in there that we can't see, but both of those things are expanding. And so how could we draw a picture to illustrate that? And it gives you several other examples there as well. And then because this could become a very complicated idea and we could easily move into atoms because those are things that we cannot see, you can look at the assessment boundary and identify that our students in 5th grade do not have to know about atomic scale. So they don't actually have to know that there are things called atoms. You could go as small as there are air particles that we cannot see, right? So they'll learn about atoms in middle school and even more so in high school. And so those are things that you don't have to feel like you're required to do in 5th grade. The disciplinary core ideas here in the center would be specific content that students would need to learn that would support them in doing that performance expectation. As Julie mentioned earlier, they would need to be able to develop a model. Again, this supports that performance expectation. And the final box is the cross-cutting concepts here, talking about how objects exist from very small to very large. And so we're looking at like scale here, which also supports that performance expectation of particles being too small to be seen. And so you can kind of see how the 3 of these foundational boxes down at the bottom are all tied together in that one standard. And then what might that look like in a 5th grade? Like how would I assess that? And here are some just examples that you could use in 5th grade to look at particles are really small. And you can see that we have a balloon with air particles. Might be what inside of a basketball looks like. And you can just see that they would be like, there's a bunch of particles in the center, or our dandelions. That these particles get smaller from big to small, and helping students understand that this idea really builds off of a matter idea that occurs earlier in elementary school, that big things can be broken down into smaller pieces, and 5th grade then goes one step further, that those smaller pieces could be so small that we no longer see them. These types of examples that you currently see on your screen are things that we will be discussing in our next meeting at the end of October, when we start talking about using phenomena to engage students in their learning. So as you're planning then for instruction and looking at the standards to support the planning, it's really important that you understand the expectations of that standard. You can do that by looking at the clarification statement or the assessment boundary or those foundational boxes, which identify the dimensions students should be utilizing to meet that performance expectation. It is helpful to know what comes before or after in grade level learning progressions, which is why we have those vertical progression documents. I know when working with elementary teachers, especially, the burden of everything my kid has to know is kind of removed, because then they realize that, oh, I actually don't have to talk about, like for fifth grade, that example, atoms. Atoms isn't my responsibility in fifth grade. And so that really helps narrow in the content that should be taught. And then understanding the science concepts associated with the standards, a lot of times that can be a little more difficult if you are not familiar with that content area. Like, I am a physical sciences background, biology, I have to do some extra reading. And so there are different supports out there that do provide the science concept support that you might need, such as even your curriculum resources at your school. When I first started teaching, I'd open up a textbook several times to make sure that I was teaching the content right, just in case I had my own misconception and I didn't want to teach students that misconception. Different resources you can use for planning for instruction here are the Oklahoma Academic Standards for Science, the standards document, which I am now linking inside the chat box. That standards document has all of the standards pre-K-12 and the introduction pages that were shown to you earlier that had the general descriptions of each of the dimensions. All of that is located in there. We are also creating grade level standards documents, so that if you are wanting to like print off just, sixth grade or just biology or just second grade or whatever you were looking for, we're going to have those documents available so that you don't have to like download the PDF and then try to find your particular pages and only print the right pages and that kind of thing. So we will be providing a document that is broken down for you. The vertical learning progression documents are also relinked inside the chat box. Remember, those are what we use to help identify what comes before and after each of the dimensions inside the standards. The other instructional support that I want to mention are our Oklahoma Science Frameworks, which I will also link in the chat box in case you want that. The Oklahoma Science Frameworks, one, you can find the standards there. And then we also have these things called instructional bundles. And what they do is that teachers were selected to bundle standards so that it would represent a unit of what they would teach in the classroom. We all know that teaching in the classroom time is limited, and we simply cannot teach each standard individually, nor should we want to, because very rarely do we look at the world around us and think about only one standard that might address that particular thing. So like if I'm looking at a tree, when I'm thinking about a tree, I'm probably not thinking just about photosynthesis. I might be thinking about structure function, like what is the purpose of the roots? How about the leaves? What do they do besides maybe photosynthesize? Like that kind of thing. So teachers got together, bundled standards, and created these instructional bundles that include In a Nutshell, which is friendly non-science language, trying to explain what that particular bundle entails. The three-dimensional storyline, so then it goes into more specific detail and provides examples of how to integrate the dimensions within that particular bundle. There's a list of student actions, so if you're looking for like lesson level objectives kind of thing, there is a list of those. And then we have also included common misconceptions, which are paired with the actual concepts, and those are also provided inside of that. Now, the one caveat here is that the Oklahoma Science Frameworks are currently aligned to the 2014 science standards. Revisions are going to begin this year, which brings me to our next slide. Because there's a couple of things that I'm going to ask of you. So the first thing is, for our frameworks, we want feedback on what is good, what is bad, what needs revamped, that kind of thing. So we are looking for feedback, which I will provide that link inside the chat box. So if you are familiar with the frameworks, take the survey. If you are not familiar with the frameworks, please take the survey. We are also asking questions about usability and like how many clicks does it take to get to something kind of thing. Does it make sense on where things are located? We also provide some links to the math frameworks and the social studies frameworks and ask you to identify things that you really like and their supports, and would you like to incorporate those into the science frameworks. We are going to be revising all of the frameworks, so kindergarten through 12th grade, and we are going to be developing new frameworks for pre-kindergarten, environmental science, physics, and earth and space science. We hope to have applications sent out the beginning of October for educators to participate in the development of these frameworks. We want to work with educators that are interested in revamping these. So please be on the lookout for that announcement, which will be sent out via the OKSci newsletter and on Facebook. And I do hope to have that out. First week of October is the goal. My proposal is being submitted on Friday, and we'll just kind of see how long it takes to get from that to the next step. But if you have any questions about participating in the frameworks revision, you can please feel free to email me, and I can answer those questions. All right, so as I mentioned before, this OKSci Education 101 I really developed this because I had a lot of questions about general understanding of our science standards, and so I wanted to create kind of like a little course where we progress through understanding science education, which is why we started with the standards today. Next month's meeting will be October 28th. And our topic will be engaging students with phenomena. And then in November, we might be focusing on specifically driving questions board, and then getting into student discussion as a highlight in in January. We will probably skip December just because that's a busy month in general. You will want to register for each of the meetings. I'm pretty sure the link does not change, so the link that you use to join the meeting today should be just fine next time. But just in case you do lose it, just know that you can register more than one time. It doesn't like block you out or anything like that. Okay. We do have some just general OKSci monthly meetings as well, which is the second Wednesday of each month. Next month, we will be talking about classroom assessments, how to do that if you are in person or if you are virtual. Susan Ray, who's the Oklahoma Excel Science Specialist, will also be joining us because the Excel team has developed some self-paced learning modules through the OKEdge platform, which is a new platform this year. And she's going to kind of discuss what that looks like, which is their like a light version of the OK Excel program. But it's very, very cool. because it really gets you looking into your practices and what it is that you are doing, and then is it actually engaging students, all around the focus of student discourse. And she's going to join us in October to talk about that particular module that she put together. All right. Now, I am all done. I really do appreciate you coming, and I really do hope that you come in October. I am going to stop recording.